Okay, so now we're going to have our demo student go through the scatter plots exercise 1. Okay, so again we have a Desmos activity. So we go into Desmos. We're demo 6th graders, so we go. Okay, so independent or dependent variable. So if you look at this, you say, oh, what is that? Right? So and you're going to see that it's the thing you control in your experiment and the result of it. And so when you have in the ocean how deep you are, the depth, and the temperature, what depends on the other? So, in other words, does the depth depend on the temperature of the water? No. So if you think about it, right, as you go deeper, the water gets colder. Okay, so the independent variable is the depth, and then as you go down, the temperature changes. Okay. And so 1, depth is independent, and 2, the temperature is the dependent variable. Now this is a little tricky because we're going to have to go back and forth. And so I'm going to go over and go to the next one. I have to remember 176, 273. So here it says, let me make this a little bigger. It says use the plus icon to add a table. So we're going to hit the plus here, and it adds. So we select table. Okay, so remember what we had. So our x is going to be water. So what was it? 100. Okay, and then I click in here 76, and I hit enter. And now I want to go over here, and I think it was 273. Okay, so we're just building our table. And notice I can go back and say 176, 273. So 30, 370, 466. So I say, okay, let's add some more. So 300 was 70, and 400 was 66. And you're thinking, oh, this is really tedious, why do I have to do this? I think it's a limitation. So 561, but it's good to learn how to do that table. 561, 600, 561. So I click in here and then I go here. So 561. Okay, so if you look at this one, you say, well, I went down 100 and I changed 5. I went down 100, changed 4. Went down 100, changed 3. So it does seem like the so it seems like we should be going a little bit steeper here. Okay, so what's our next one? So 600, 656, 752. 656 down 5, and 700 was 52. 52. Okay, and we've got 2 more to do. So I do 848 and 943. 848 and 943. Okay, so there I've got my table, and now we can zoom in. And we can see that, yeah, so it was a little bit shallower. So as we first went down, the temperature didn't decrease quite as fast, but then you can see we got this trend, and so beyond 300 feet it's fairly consistent. So let's see what they want us to do. So we've added our table, and is there anything else that we need to do in this? So let's zoom out. Let's see if I can zoom out. So I click in here and I zoom out. And it seems like we've done what we're supposed to do here. Okay. Let's see what the next slide has us do. Okay, so what's our relationship? So we say, well, our relationship seems to be that as the depth increases, the temperature decreases. And if you want to put it in shorter variant, water gets colder as you go deeper. And especially if you've been swimming in the lake, you'll notice this. It's a very strong tendency. It's warm at the surface, but then you get down a little bit and it's much colder. And so what do you notice about these? In the red, we notice red, so increases. So y increases as x increases. And the orange, y decreases as x increases. And what else we notice is orange is not as steep, so it has a negative, but fairly shallow slope, whereas red has a positive, steep slope. And then we say, well, what about this guy? Okay, and so as we look at this, we say it's decreasing. So, and in that case, you say as x gets bigger, it is a linear association. So is it in a line? It is. So it's not in a curving thing. So points all close to a line. And if you wanted to, you could actually get a slope for this line. And so what we're going to find is that there's a lot of relationships like this in business and in science, in nature, where as something increases, the other decreases at a constant rate. And so we go on and say, how about this one? And so in this one you can see, yes, of course, we have this nice central tendency of increasing, at y increasing as x does, and the slope's about 1, right? But then we have a couple points that are not really in the part. So we're going to circle these outliers. Okay. So they are not with the program. They're not really in that same category, right? So, and we'll think of some examples. Okay, so we have this relationship between x and y of 1 to 1, and they don't have that. Right? And so you might say, well, my example was, the more I studied, the more points I got on the test. Okay, so then here's the smarty pants. Hardly studies, got a lot of points. These people studied and studied, and sadly they weren't studying effectively, and didn't get it. Now we want to create a scatter plot with a non-linear association. Okay? And so this is a case, for example, of when you think about what the graph looks like of squaring x. So graphing y equals x squared. Okay, so we say, oh, well, for 1 we got 1, and for 2 we got 4, and for 3 we got 9, and for 4 we got all the way up here even to 16. And then maybe somebody, then for 5 you only got 1, so there's an outlier, and for 0 you got 12. But you can see that curving formation, so as x gets bigger, y increases faster and faster. And the example I use is that you go babysitting for a bunch of very difficult children. So you charge $1 for the first hour, but you charge $4 for 2 hours and $9 for 3 hours, because the longer you're there, the more difficult it gets. Okay? So there is a relationship, but it is exponential, not linear. In other words, it has that graph that you've come to see when things grow not at a constant rate, but at an increasingly fast rate. Okay, so here we have the height of the runner and the weight of a runner. And what we're saying is that we think there's a relationship. As a runner gets taller, he's going to, in general, become heavier. It's not always true, right? People have different builds. So you can imagine someone who's short but built like a football player. as opposed to someone who's tall, built like a more classic kind of basketball player. But in general, the weight goes up. So independent variable height is the height. And as we look at the height, dependent, we're seeing this relationship with the weight. And so the surprising point, of course, is a height of almost 0. So the point near 0, 0 is high. Near 0, 0 is surprising. 0. Okay, so that seems like it was maybe a data entry error. Entry error, right? And then we do have this very tall person who weighs a lot too, okay? And that guy's sort of the outlier in that. So these two guys here are outliers, much taller and bigger. So it's as if you snuck a couple of adults onto the middle school team, for example. Okay, so what does it mean to have a positive? So positive means as x increases, as y increases. And that certainly is the case here. And so could we draw a line? Yes, line would come close. Okay, so now we have one where we see that it's a negative relationship, right? So that as the level of interest in the ride increases, the waiting time well, so this one seems a little strange to me, right? I guess I would say I would do it the other. I'm thinking, well, the longer you wait, the less interest you have in the ride. This seems to say as the level of interest in the ride increases, the waiting time decreases, which doesn't seem right to me. I think it would be the other way, right? It's more that there's more people in line for the ride because it's one that's really popular, so the waiting time would go up. So I don't understand this one particularly. So this is a negative one, right? There's this negative relationship. So, but as I say, I don't think that's a very good example, so I wouldn't worry about that one. Now, here's one where we've got your grade in math and your grade in choir. Okay? And so what we see is that this point up here to the right, what would that be? It would be a high grade near 100 in math and a high grade. So above 90 in math and above 90 in choir. But we also have someone who has a very good grade in math, so a grade of, oh, well, this is 95, right? So 95, sorry, I read it wrong. So in the 90s, but a low grade, not even a passing grade in choir. Okay, so we would say no relationship. There's no relationship between grade in math and grade in choir. So when your data is all scattered around like that. Now here's one where you say, oh, well, there's a very strict linear, there's an exact relationship. So you can see these points are all on the line. Okay? So this isn't, there's no variation at all, right? Is that you can convert from a degrees in Fahrenheit at exactly the same rate. So as you go up a degree in Fahrenheit, you're going to have, so there's a precise slope. So there's a line that goes, so this is an exact linear relationship. And you could think about this in any conversion, right? So if you were to convert from, say, pounds to kilograms, you get a line like this where all the points would be exactly on the line. And so here's one, and what you notice here is that it's not linear. Okay? So bottle rocket versus time. Right? And so what happens is that the height of the bottle rocket goes up, and then it reaches its highest point. And as you know, what comes up must come down, so then it comes down again. Okay? So it's not a linear relationship, okay? And this is in fact an upside-down parabola. And so there's first positive relationship for the first 20 seconds, and then a negative relationship in the second 20 seconds, but always non-linear. Okay, so this is a very interesting set of data for us, because we haven't really developed the math to be able to work on this. But what we see is a positive, but you can see how I'm going to so I'm picking up height, and now I'm slowing down. So if you think about what happens with the rocket, it goes off really fast, and it slows down, but it's still going up, reaches its highest point, and now it's going down, and as it goes down, it starts going faster and faster. Okay, and so if you wanted to, you could build in your own scatter plot here. So let's see how